Hello everyone. Last time we have done the number of stereo center, chiral center and stereoisomer. Now today we are going to talk about R and S naming in wedge dash projection. Wedge dash. So wedge is the solid line and dash is this. It's nothing, it's just like a single bond, but difference in direction. So wedge is generally, out of the plane and dash is below to the plane. So let's talk about the case first. When the lowest priority on dash, then move 1 to 2 if it's clock, and 2 to 3 if it's clock, then R, anti-clock S. We are going to decide the priority over here. So you can see bromine have the highest atomic number, which is would be 1, oxygen 2, nitrogen 3, hydrogen 4th. Now we can see my lowest priority on the dash here, which is hydrogen. Now move 1 to 2. So 1 to 2 is this one. Arrow is moving counterclock, which means anti-clock, so it would be S. Try another one. Here it would be my 1, this bond 2, carbon 3 and hydrogen is 4th. I discussed already how to decide the priority. And when the first atom is same, then compare to the next atom, okay? So now my lowest again dash, move 1 to 2, 1 to 2 going clock, so it would be R. One more thing I would like to tell you, whenever the lowest priority, suppose we have to move 1 to 2, and 4 is and third is coming between them, then always cross the fourth priority. For example, suppose we have this is 2, this is 4, this is 3. Okay, it doesn't matter what's my lowest one. Suppose you can keep this one on the width, this one on the dash, because like this. This is solid single line, okay? This is just a single bond. So now you can see between 1 to 2, we have 4 and 3. So we can cross always the fourth priority, the lowest one. Clear? We do not cross the third one. Now case 2. When the lowest priority on wedge then flip your answer. What does it mean? Look at this example. So in this case, bromine would be 1, oxygen 2, nitrogen 3, hydrogen 4. Move 1 to 2. Going clockwise, we know that clockwise is generally R and anti-clockwise is S. But whenever the lowest on the wedge, so you can see here my lowest on the wedge. So flip your answer. So it's moving clock is generally R. So if you flip your answer, it would be S. Clear? Another example. 1, 2, 3, 4. Move 1, 2, 2. Generally, clock is R, but lowest on wedge, so it would be S. Okay. Now the very important point, when the lowest is neither wedge nor dash. For example, this case. So how can we decide the R and S over here? So first job is to decide the priority. So bromine would be 1, oxygen 2, nitrogen 3, and hydrogen is 4. Now we have the rule where the hydrogen should be, means the fourth priority should be on the wedge or dash. So we can exchange here, and it's my choice to keep hydrogen either wedge or dash because we have the rule for that. So I am going to do the lowest priority, the fourth priority on the dash. Okay. So if you are going to put the fourth priority on the dash, then the rest would not change. So fourth here, and 1 would be here, 2 and 3. I have done just one exchange. 1 is an odd number. Okay. I just switch hydrogen with the dash, this. So this is overall just one exchange. Now you know that my lowest on dash here, move 1 to 2. And we know that when the lowest on dash and clock is R, then NT would be S. So this is moving clock. Clock is generally R. So we have done one exchange. Okay. So whenever you are going to do one exchange, it means the answer must be reverse. So this is R. So it should be S. Okay. This should be S. So this is the way you can figure out the R and S when the lowest is neither wedge or dash. Make sense? So sometimes, it's important. So we can do the exchange over here. Now the next is how we can memorize this trick. So look at the rule. DAS. This is the best way to memorize the R and S in wedge dash projection. So D stands for dash. Dash means when the lowest on dash. Lowest on dash. A stands for anti-clock. Anti-clock. And S would be the configuration. So rest of the condition is quite easy now. Now you know that when the dash is lowest on dash, NT is S. So dash clock would be R. Okay. And wedge is just opposite of dash. Wedge is just opposite of dash. It means if wedge NT, what should be R or S? So you know that dash NT is S. It means wedge NT would be R. And dash clock is R, it means wedge clock would be S. Simple. So try to memorize just one case and rest you can draw like that. And this is the rule for this. Dash. Now next is R and S in Fischer projection. Fischer projection. This is the horizontal and vertical line, and this is called Fischer projection. So case first, when the lowest on vertical line, when the lowest on vertical line, then move 1 to 2, clock R, anti-clock S. Now we will decide the priority. So bromine would be 1, oxygen 2, nitrogen 3, and hydrogen 4. Now move 1 to 2. This is going anti-clock, so this should be S. Okay. Now case 2, when the lowest on horizontal axis, horizontal line, then flip your answer. Flip your answer. So simply we can say the rule for horizontal is identical as wedge, and rule for vertical is same as dash. Clear? So simply we can say this is dash 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 and it should be wedge. For example, hydrogen, bromine, OH, Cl. So bromine 1, chlorine 2, oxygen 3, hydrogen 4, move 1 to 2. This is going anti-clock and we know that anti is S, but lowest on horizontal. So flip your answer. So it would be R. So this is the rule for, Fischer projection. And I think it's good enough for R and S. And if you want to memorize the rule for this, you can memorize this VCR. In late 90s, we have a video cassette recorder. So you can memorize like that, VCR. So V stands for lowest on vertical. C stands for clock. R is my configuration. Now rest you can write down. So if vertical clock is R, it means vertical NT would be S. And if vertical clock is R, then horizontal clock would be S. And if vertical NT is S, then horizontal NT would be R. Simple. So VCR and HAR, HAR. Okay. So these two lines is good enough. Okay, so this is R and S in Fischer projection. Now we are going to talk about the relationship between the molecules. This is very, very important topic. Relationship between molecules or compounds. So first case, I am going to discuss single chiral center. Single chiral center. Whenever we have a single chiral center, we have two kind of relationship. One is identical. Second one is enantiomer. Enantiomer. So we have two rules to figure out the relationship. One is RS method. Second is exchange method. And in enantiomer again RS method and again exchange method. So most of the students, familiar with the RS. Now today we are going to discuss exchange rule and then we will go back to the RS. So what is exchange? Exchange is of two types, even and odd. Even and odd. So what is the rule for even and odd? What does it mean? It means after odd exchange, compound would be enantiomers. And we know that enantiomers are non-superimposable mirror image. Non-superimposable mirror image. Okay. And odd means after, even means after even exchange, compound would be identical. And they are superimposed mirror image. Superimposable mirror image. And they have same configuration. After even exchange, configuration remains same. Means R will remain R and S remains S. But in odd exchange, they have different configuration, opposite configuration. It means R would be S and S would be R. So even means even number like 2 and 4. Odd means odd number like 1 and 3. Let's talk about example. So we have to find out the relationship between these two molecules 1 and 2. So first job, we are going to compare the changes in both the compound. So if you look at bromine and chlorine, they remain same. You can see the position is same. So there is a mutual exchange between OH and NH2. You can see. So there is a mutual exchange between OH and NH2. It means overall it's just one exchange. One is an odd number and odd means enantiomer. So 1 and 2 enantiomers. And we know that enantiomers have opposite configuration. It means if it is R, it would be S. And if it is S, it would be R. Make sense? And we have the rules for R and S. Let's figure out R and S. So if you are going to decide the priority, bromine 1, chlorine 2, and oxygen is 3, nitrogen is 4th. Lowest on my horizontal axis, so we have to flip. So 1 to 2 going anti-clock, we know that anti is S, so it would be R. So I'm 100% sure, definitely it should be S. So let's find out bromine 1, chlorine 2, oxygen 3, nitrogen 4. So 1 to 2 going anti-clock, lowest on my vertical axis, so no need to flip. So it should be S. So you can see. So I'm going to remove the bottom one. So they have opposite configuration because they have odd exchange. Look at this example. So again, the same thing. Look at the groups. So you can see there is exchange between bromine and NH2, and again exchange between OH and Cl. So overall, it's two exchange. 2 is an even number. Even is identical. So identical means same configuration. So if it is R, it should also be R. And if it's S, it should also be S. So it's your job to find out R and S over here. Okay. So this is even an odd exchange. Sometimes the exchange is not such a easy, like we can directly, compare the groups, but sometimes it's like that. Look at this example. You can see here, the direct exchange is not there. You can see here OH is, look at the OH and H. OH goes vertically down and H goes vertically up, but here it is horizontal and vertical axis. So how can we do this? We will fix one by one. We are going to make P like Q, but one by one. Each group we will fix one by one. And you can start with any group. Suppose in Q, bromine is my horizontally right. So I would like to fix bromine horizontally right. So hydrogen would be in place of bromine. And let's draw this. So bromine, H, OH and NH2 will remain same. So now my bromine is fixed. Now the next group, you can start with anyone. Suppose OH. OH is vertically down. So you can see here, we can keep OH vertically down. So NH2 go vertically up. So again, we can draw OH, NH2, bromine, H. Now my bromine and OH is perfect. And now it's easy for you to exchange NH2 and H. You can see NH2 is in the left. So one, another one. Overall, 3 exchange 3 odd. Odd means enantiomers. Okay. So what is enantiomer? Let me tell you something about it. Enantiomers are non-superimposable mirror image. Non-superimposable mirror image. And they have same physical property. Why they have same physical property? Because they are just a mirror image. There is no change in bonding pattern, no change in intermolecular forces. It's just a mirror image. Okay. And now we are going to apply both the rule RS and exchange. So let's talk about the very first RS. So here we can say both the compound have opposite configuration. Both the compound have opposite configuration. Opposite configuration. It means if it should be my R, it should be S. So 1 and 2 are enantiomers. And we can do the same thing in wedge and dash as well. Okay. So if this is my R, then it should be my S. So they are enantiomers. What is exchange rule? Exchange means both compounds should have even number of exchange. Even number of exchange. Like this. They both have even. Okay. So this is, oh, sorry, I made mistake. We are learning enantiomers, so they must have odd number of exchange. Oh, sorry. They must have odd. Okay. Next is identical. Identical means superimpose, and in RS method we can say both compounds should have same configuration. Should have same configuration. This is called RS method. Both the compounds should have same configuration like this. R, R, S, S. So they are identical. Next exchange. So here we can say both compound should have odd exchange like that. Odd. Okay, so this is enantiomer. So what is superimpose and what is non-superimpose? So look at this hand, my left and right. Now look at this is thumb on thumb, little finger on little finger. So this is called superimposed mirror image. This is identical. What is non-superimposed? Non means like this, you can see. So this mirror image is called non-superimposed, like mirror image. You can see if I'm going to keep a mirror over here. So look at this image, the left and right. So this is called non-superimposed mirror image, and this is enantiomers of each other. Suppose we have this molecule and I want to draw its enantiomer. Okay. So what is the possibilities to draw its enantiomers? So whenever you have a wedge and dash projection, the best way to draw its enantiomer, you can just switch wedge with the dash and dash with the wedge. Simply do not change the geometry and or the bonding of the compound. Means this ring and this bond would remain same. The downside wedge would become dash and an H2. This is enantiomer. There is another thing we can draw, it's in enantiomer. You can keep a mirror over here and now look at the drawing. This is also in enantiomer. Because we kept mirror in the left hand side, right hand side. Okay. If we are going to keep a mirror over here beneath the compound, then it should be like this. And this one also in enantiomer. Are you sure? Let's find out. Here dash is my H. So nitrogen 1. This bond would be my 2. This is 3. This is 4. 1 to 2. Going clock, this is R. Here dash is my H. This is my 1. This is my 2. This is my 3. This is my 4. 1 to 2. You can see going anti-clock. So this is S. So opposite configuration. So this is in enantiomers. Okay. So it's just a mirror image. But the best way is you can just change the wedge with the dash. For example, we have to draw the enantiomer of this compound. So keep everything same. Now change wedge with the dash and dash with the wedge. So this is dash OH. This is the wedge chlorine. This is the dash bromine. And this is the wedge OH. Okay. So these are enantiomers. If you are going to draw its mirror image as well as you are going to change the axis, then those things are not the enantiomers. Okay. For example, suppose we have this compound OH and suppose this one. So let's try to figure out R and S. Okay. So 1, 2, 3, 4. 1 to 2. Going clock, clock is my R. 1, wedge is here H. This is 2, this is 3, this is 4. We can cross the fourth. 1 to 2. Going anti-clock. Anti is S. Anti is S, but flip your answer, which? So it would be R. You can see same configuration, so identical. So I am saying here, if you are going to keep a mirror image and you are changing the axis as well, so it's overall just two exchange, one with the image and one with the axis. So two exchange means even number of exchange, and even number of exchange produces identical. Okay. So whenever you have a structure and it's like whenever single chiral center containing compound, and you can apply this for multiple chiral center as well for identical and enantiomer. We are not talking about diastereomer at this moment. So this is the best way to answer this question. First, find out the odd and even number of exchange. And if it's complicated, then go with the R and S. And if it's a direct mirror image, then no need of it. You just say this is enantiomer. For example, generally in DAT, we have this kind of compound is very common. Look at this. My question is, what is the relationship between 1 and 2? 2 and 3? 1 and 3. And you have two options, identical and enantiomer. Now you have two choice. You can apply either RS method or exchange. So let's apply exchange directly because it is not going to take too much time. So if you compare 1 and 2, you can see bromine left, and H2 vertically down and H2 vertically down. So there is just one exchange between OH and H. So this is just odd. Odd means 1. 1 means enantiomer. So this is enantiomer. Simple. Now second and third. H, OH, OH. So now there is exchange between bromine and an H2. So again one exchange, one in again odd is again enantiomer. Now look at 1 and 3. Exchange between OH and H and exchange between Br and NH2. So overall 2. 2 means even means identical. Okay. So this is the best way to figure out the relationship, and you have two choice. You can use RS method as well. So this is for single chiral center, and in the next session we will talk about multiple chiral center, and we have additional relationship which is called as stereomer. Thank you so much.